Hello and welcome to this special episode of the Operating System Development Series. Today we are going to solve a few problems that appeared on Windows. In the end we will have successfully compiled the kernel we created in section 2 in the first episode. Now let's see what happens when we try to build what we created in the last episodes under Linux. So let's download the project files. Here they are. I'm going to download and let's extract these files. I have created the folder called dev in the C drive where I have a couple of tools, so let's extract it there. Okay, here are all the files. You can close this. Let's open Cygwin and see what happens when we try to compile. The file is located in cig drive /c/dev/myos. Build it. Okay, first we get a compiler error, a mount error, so we get errors. It doesn't work. Okay, so I'm going to exit Cygwin. Now I'm going to open the browser. We need to download a tool called Virtual Floppy Drive, so let's type Virtual Floppy Drive in the search bar. And let's go to the sourceforge.net link. And download this application. I already downloaded it, so what I have to do is extract these files. I already did that in the dev folder, in a new folder I created called VFD. Once you do that, open the VFD folder and right click on vfdwing.exe and go to properties. Now in the compatibility tab, enable this option which says run this program as administrator. You need administrator privileges to run this application, otherwise you'll get access denied errors. Now because you Windows users may be a little bit behind, I'm going to show you how you can create the virtual floppy disks we created under Linux. First let's navigate to the work directory. I have chosen c/dev/myos. Okay, so we need to generate two files. To do that, I'm going to create a new text document, call it auxiliary.img and delete the txt extension. Same thing for the second file, call it myos.img. Now launch Cygwin. And let's also navigate to the work directory. /cig drive /c/dev/myos. Now let's type in dd, which is the command we are going to use. We used it on Linux too. So type dd, block size will be 512 bytes. Input file will be /dev/0, so it's going to be filled with zeros. Count 28, 80 blocks. That means 1.4 megabytes, exactly how big a floppy is. And output file will be, let's start with auxiliary.img, and I'm gonna copy the same command using the up arrow and replace auxiliary.img with myos.img. Next we need to put GRUB on the first image, so let's open the browser. We are looking for a file called GRUB-0.97 and the compiled version is i386-pc.tar.gz. Just pick a mirror that works for you. I'll pick the first one, and this is the file we need right here. GRUB 0.97. Okay, so let's download this file. Let's extract to the work directory, and inside the GRUB folder let's take the stage 1 and stage 2 files. We'll only need these two, so let's delete the rest of them. Now let's go back to Cygwin, and we need to write stage 1 at the beginning of auxiliary.img. Immediately after stage 1 we need to write stage 2. Now we know that stage 1 is only 512 bytes in size, which is exactly the size of a sector on a normal floppy disk. So let's type in dd. Block size is 512, just like before. Input file will be stage 1. Count will be 1, a single block, so that means a total of 512 bytes. Output file is going to be auxiliary.img, and also let's specify conv equals no trunc. This means that it won't truncate the output file. Now for the second stage, I'm gonna copy the command using the up arrow and replace stage 1 with stage 2 and count with seek. Now blocks are indexed starting from 0, so block 1 means the second block. Okay, so we have finished with auxiliary.img. Now there's another thing we need to do before we continue, and that is we need to format myos.img and put stage 1 and stage 2 on it. Okay, so let's go back and open VFD. We just downloaded. Okay, open VFD. Now you'll have to click install first. Now I'm gonna start it, and under drive 0 the drive letter is A. If it's none you have to change it and select A. Now let's open a file, and I'm gonna select myos.img and press open. Now make sure the disk type is a file, because so that the changes will be written to the file, and press open. A new drive will appear in my computer, floppy disk drive A. So let's go back to the work directory and copy the two stage files. Now before we can open the floppy drive we need to format it. Windows will notify us. Choose format disk, disable quick format. It's gonna be quick anyway, so press start and press OK. And now we can close this window. Now let's create a new folder called boot, and inside I'm gonna paste stage 1 and stage 2. And a third file will be needed. Let's call this file menu.cfg. This is going to contain the GRUB menu. Okay, so basically this is what happens. The default entry is going to be the first one. The index starts at 0. The timeout, which is how many seconds GRUB will wait for us to choose an item, will be 0 seconds. And it won't display the menu at all. The title of the first entry is myOS. The root directory is the floppy disk itself. The kernel is going to be the kernel.bin file that we are going to create in just a moment. And then the last instruction is boot. Okay, so this is exactly what this menu does. makes GRUB boot our kernel without tasking anything. Okay, we can close this file, the browser too, and let's go back to VFD and let's close this file. Okay, so I'm gonna click close and exit. Now, the next thing we need to do, I don't need Cygwin anymore. So I'm going to open VirtualBox. Okay, I have already created a virtual machine called testbed, so I'm going to launch it. And under devices, floppy devices, I'm going to choose auxiliary.img and now reset the machine. Now we need to insert the other floppy, which is myos.img. I already have it here. And let's type install fd0/boot/stage1 fd0/boot/stage2 and fd0/boot/menu.cfg, and let's press enter. You can use the tab key to autocomplete with the files existing. It also works under Cygwin. It's a very cool feature. Another problem we need to solve is the problem with the compiler. The GCC that comes with Cygwin and also MinGW are built to output Windows executables. Now our problem is that we need to output the files in an ELF format, which is a Linux executable. We'll have to build GCC ourselves in order to fix this problem. In order to build GCC and Binutils, first of all you need to make sure you have enough RAM memory and enough disk space. The next thing we need to do is download the source code for Binutils and GCC. So open the browser and go to ftp.gnu.org. This is the website where you can find the latest builds, the latest source codes for GCC and Binutils. Let's open the GNU folder. And you need to look for Binutils, it's right over here, and GCC. Now for Binutils, you need to look for the latest version. You may be able to sort by date and time, but I know that the latest version is 2.22.1. So pick that one and download the tar.bz2 file or tar.gz and also GCC. You need to download the latest version, which in my case is 4.6.1. And go and download GCC-4.6.1 right here. And download this one. I have already downloaded them. It's gonna take some time to download, depending on how fast your connection is. The next thing you need to do is extract these two. Okay, my Binutils download is finished. You need to use an archive program that won't mess up the file names. For example, WinRAR or the tar command in Cygwin. If you don't, you may have problems later. The build may fail. Okay, so we need to extract both of these archives. I'm just gonna show you Binutils. You need to extract to C, Cygwin, and look for USR, SRC, and press OK. Now I already extracted this, so I don't have to. But this is what you have to do, and same for GCC when it finishes to download. Next, we need to install a few programs from Cygwin, so we need to launch the installation for Cygwin. I still have that installation in my downloads folder. Click next, next, next. pick a mirror that works for you. And there are a couple of programs you need to make sure you have before you continue. First of all, you need to have GCC. So go into devel, make sure you have GCC checked, GCC, G++, GCC core, and that's pretty much it. Another program you need is make. So under devel, look for make. Make sure you have it installed. You'll also need flex. Under devel, here it is, flex and bison. Make sure you have this one installed right here. You'll also need libgmp-devel. You'll also need libmpfr/devel library, this one right here, and you also need libmpc/devel, that is the MPC library right here. Make sure you have those installed. Click next. Another important thing is to make sure that you don't have any other GCC port installed like MinGW or DJGPP. If you do have any other port installed, you need to go to the C drive or where it is installed and rename that folder. For example, I have MinGW and you have to rename it. Say I'll add an underscore at the end and press enter. Okay, now once you do that, you can launch Cygwin. And now you need to create a few environment variables. We'll use export in order to do that. So export prefix equals /usr/local/cross. This is going to be the destination folder for the GCC and Binutils installation we are about to do. Now the target will be the i586-ELF platform. Now we need to navigate to the src folder. We extracted the source codes in. So cd/usr/src. Now create two directories in this folder using mkdir. The first one will be called build-binutils and the second one build-gcc, and press enter. I have already done this, so that's why I get an error. Now navigate to the build-binutils folder, and now you need to configure binutils in order to build itself properly. Type in 2 dots, this means the previous folder, and the binutils source code folder, and then configure. Now the target will be equal to $target. This way we are referencing the environment variable we created previously. The prefix will be $prefix, and also disable NLS. This is going to make the installation a bit faster. Now press enter. I have already done this, so I don't have to. This is going to take a few minutes, like at least 5 minutes, depending on how fast your computer is. Once that finishes, you need to type make all and press enter. Now this is the lengthiest process of all. It's gonna take about half an hour. It took me 40 minutes. I don't have a great computer, but it depends a lot on how fast your computer is. Okay, so in 30 minutes after this is done, you type make install, and this is going to be pretty fast. The next step is to build GCC. Okay, so navigate to the build GCC folder you created earlier, and we'll need to export another environment variable. This time we'll export path equals path, $path. This means that we are appending to the path variable, which already exists, column $prefix /bin. This means that we are appending to the path variable the path we installed Binutils in. Now the next thing to do is to configure. To do that, we launch configure, which is located in previous folder /gcc version number. You can always use the tab key to autocomplete the name of a folder or a file. And type configure. OK. The target will be same as before, target with $, prefix equals $prefix, disable NLS, also enable languages C and C++, and without headers. This is also going to take about 5 or 10 minutes depending on how fast your computer is. Now make all/gcc and press enter. This is the lengthiest of all processes. It is going to take you at least half an hour, maybe more, maybe an hour, I don't know, but it's a pretty lengthy process. And the next thing you need to do is install GCC. So make install/gcc. This is gonna take 5 minutes or so, not very long. Okay, and the last thing we need to do is build libgcc. So to do that, type in make all/target/libgcc and press enter. This is not gonna take very long, maybe 5 or 10 minutes. And make install/target install-target-libgcc. This is gonna take 2 minutes, I don't know, maybe more. Now I already did this, so I kind of skipped, and now instead of pressing enter, I pressed Ctrl+C, so that's why nothing happened on my screen. I just wanted to show you what you have to do. Okay, there is one more thing we need to do before we can build the operating system and the build to succeed. Let's edit the environment variables. And click environment variables. If you have Windows XP, you'll have to go to properties for my computer and look for this button right here, which says environment variables. Now under system variables, look for path. It's right here. Click edit. Now let's look for where GCC was installed. Go to your Cygwin installation, USR, local, cross. And inside the bin folder, you'll see GCC and all the tools we have built. Okay, so what you have to do now is copy this path and put a semicolon at the end and paste it. And then press OK. I already did this, it's right before this Java path, so I'm just gonna hit cancel. And when you're done, press OK. Now that we have finished with GCC and all the tools, we can go back to our operating system and build it. So let's go to the Word directory. And let's edit build.sh. Okay. Now we are going to replace GCC and LD with the tools we just built. Let's create 2 new variables. First it's gonna be compiler, and the value will be i586-elf-gcc, and this is what we're gonna use to compile instead of this GCC. And linker equals i586-elf -ld. And now we can replace GCC with $compiler. This way we are referencing to this variable here. And instead of LD, $linker. Okay, so we have to go and we have to open VFD. And we'll have to start the driver if it's not started. And go to the drive 0 page. And let's open myos.img and press open. I'm gonna keep it as RAM and open. Now open Cygwin, and we'll have to mount the A drive to a new folder. I'm gonna create a new folder called mnt in the root folder. And inside mnt I'm gonna create another directory called floppy. And go back to our script. So this is what we have to do. Make sure it's mounted, so mount A in /mnt/floppy, and then copy the kernel in that location. Copy kernel.bin in mnt /floppy. And you can remove the rest of the commands since they're not needed. Open Cygwin, navigate to the Word directory, which is /cygdrive /c/dev, in my case, /myos. Now I'm gonna execute build.sh. And there you go. No error messages, no anything. The build succeeded. Now let's test and make sure everything works. Going to open VirtualBox. Okay, and now launch testbed. And in devices, floppy devices, choose the host drive A. And now you can restart this virtual machine. It works. That's what matters. Now it works. This is the end of this episode. We'll see you next time.